There are multiple ways to prove that a quadrilateral is a parallelogram. The first way is by the definition of a parallelogram. If we have a quadrilateral and we can show that the opposite sides are parallel, then by the definition of a parallelogram, we have a parallelogram, a quadrilateral with two pairs of opposite sides congruent. But that's not the only way to prove that we have a parallelogram. Theorem 8.7 says, if in a quadrilateral both pairs of opposite sides are congruent, then that's enough to conclude that we have a parallelogram. Theorem 8.8 says, if we have a quadrilateral and both pairs of opposite angles are congruent, then that's enough to prove that we have a parallelogram. Theorem 8.9 says if we have a quadrilateral and one pair of the sides is both congruent and parallel, then that's enough to conclude that we have a parallelogram. And Theorem 8.10 says if we have a quadrilateral and the diagonals bisect each other, then that's enough to prove that we have a parallelogram. So these are the 5 ways to prove that we have a parallelogram. Let's look at some examples. In this diagram, if we know that WX is congruent to YZ and XY is congruent to ZW, then that's enough to prove that we have a parallelogram by, well, if we look at our examples, that's going to be Theorem 8.7. If we look at our second example, if we know that WO is congruent to OY and XO is congruent to OZ, then we have a parallelogram by Theorem 8.10. Our diagonals bisect each other. Number 3 says ZWX. Z to W to X is this entire angle, is congruent to ZYX, that's this entire angle, and WZY, W to Z to Y, is this entire angle, is congruent to WXY, this entire angle. Then that's enough to prove that we have a parallelogram by Theorem 8.8. And finally, if we know that WX is parallel to ZY and WX is congruent to ZY, then that's enough to prove that we have a parallelogram by Theorem 8.9.